1.
Welcome to the Consulting Specifying Engineer webcast, How to Specify Integrated Automation in Connected Buildings Using MasterFormatDivision 25 Specifications, sponsored by Schneider Electric. I'm your moderator, Jack Smith, and I'm happy to join you today on behalf of Consulting Specifying Engineer and CFE Media. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Question box. Type questions for our speaker in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded and you will receive an email within a week with a link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will be available with the on-demand version of the webcast. I'm happy to introduce today's distinguished presenter, Brad Bonfilio. Brad is the Consultant Solution Architect Director for Consulting Engineers, managing a national team that provides solution architecture support for the EcoStruxure building solution. Brad also recently presented cybersecurity as it relates to controls on behalf of the Winter ASHRAE Expo and BACnet International in January. Brad has more than 20 years of experience in the building management solutions, security, and energy management industry, and has a BS in industrial engineering from the University of Florida and an MBA from the University of Dallas. He joined Schneider Electric in 2007 as the Southwest Director and is Certified Energy Manager. Thank you for joining us today, Brad. The floor is all yours.
Thank you, Jack. I really appreciate that. That was a nice introduction. So today's subject, we're going to get into, obviously, you know the title, Division 25 and how to specify that. I wanted to thank everybody in the audience out there. We have over 100 in attendance, so this is great. I really appreciate it. You know, this is one of those topics that we're learning from. So if you have questions, get them in. If you have feedback, get it in. We've developed this topic towards the end of last year by need of consulting engineers, and so we were being asked for this. So we went ahead and developed this, what we think is the right 25 solution. If there's other ways to do this, we're very eager for feedback. So a little bit on what we're going to cover today. We have 1 hour here, though I'm not going to do 100 slides in an hour. In fact, I'm going to try to take about 35, 40 minutes because I do want to field a lot of questions. Division 25 does tend to lend itself for a number of questions, so I do want to allow time for that. Besides, I cringe when I see presentations and they say, oh, we're going to cover 75 slides. We only have an hour to do it, and I'm thinking, wow, okay. So we're not going to do that. We're going to go through it. So first off, a little bit on who is Schneider Electric. I like to do this because we're kind of the best kept secret in the industry. We're very large in size, over 20 billion, actually 29 billion in US dollars, 150,000 people globally. We're more well known by our brands than we are by Schneider Electric, at least in America. Square D is probably our most famous brand in America. A lot of folks know Square D and PowerLogic more than they know us, but How did we come to existence was over acquisitions, Andover, Inventus, TAC, the old CSI, Barber Coleman, all those combined to what is Schneider Electric, EcoStruxure Building Offer. And then you really have to add in there Veris, which a lot of people didn't know we owned. And then we have a lot of others like Wonderware APC, Wonderware being an industrial GUI, APC and MGE being UPSs, which most people probably didn't know we owned as well. And then we have things like ASCO that we just purchased last year, which is a transfer switch company, a lot of times with data center and critical power. So when you look at Division 25, we're probably very well positioned to go after an integrated platform because we have a number of products that all can integrate. I also wanted to mention in here we have 2 card access platforms too, Security Expert and Access Expert. So when you think about the breadth of what we can integrate and look at from an intelligent buildings, we have a pretty good footprint to start with. So when you look at, I do want to put in, these are the only couple slides I have if you want on who, what, and where. Proficient. So we do have a website. One of the things when I took over a couple of years ago, we realized is if you ever been to Schneider's website, it's hard to find anything. Most of the time I've had to Google information. So I was going to say that what the best thing to do is what we did was created a Proficient Web Portal. On the Square D side, they've had this for years. They have about 8,000 plus electrical engineers that are already registered. What we did was create one for mechanical engineers. We did not have one. So as you can see the link at the bottom, schneider-electric.us/proficient for the number 4 buildings. If you go on there, you can register, just let you know, is it a mechanical or electrical engineer, and then you can get a hold of data sheets. We have thousands of online classes that are not geared towards Schneider, but just generic in nature, from what is DDC controls to HVAC. We have professional certificates, on-demand webinars, stuff like we're talking about here. We try to put all that on there. You can get CDU PDHs that you could view video on, white papers, case studies. So it's really geared towards consulting engineers. It's not a marketing arm. If you do register and opt in for email notification, the only emails you're going to get are when we do hosted webinars across the country. And to give you an idea, we created this Division 25 like other things where we got feedback from others. Well, a year and a half ago, we got feedback is, how do we fit into, for example, ASHRAE 90.1 2016 in that standard, which is pretty difficult to meet. And so we actually did a presentation, a high-level presentation on that back in January. We had 500 people register similar to this, and about 250 people attend. So we're actually starting to see these trends and what the market's headed to be on the right direction. So what is some of the trends that are driving in this industry? When you look at connected buildings, IoT, everything seems to have a connection point today. When you look at data traffic, if you watch the news lately, what's been really exciting is 5G. If you hadn't noticed, Sprint is sort of the first one, and I'm not an advocate for Sprint, but Sprint's really the first one that's starting to tote that in major cities. And when I look at 5G and how that's going to change the industry and the world, it's going to be amazing. We're not quite there yet, but give it about 2 years, and everything's going to be a 5G. And then we're talking about having where we don't have to have a landline, a fiber connection in a lot of cases, where the speed and throughput is going to be so great that you can download movies through your phone and so forth. So it's going to change everything. And from how do you relate that back to a building? Well, I look at that as, okay, if I have controllers or devices out there that speak IP, Ethernet IP, TCP IP, versus, say, a serial bus in MSTP world of BACnet, that's sort of the difference. Maybe a 3G to a 5G is IP versus MSTP or serial. So that's the kind of thing you need to be thinking about as the trends change. When you're looking at hyper-efficient buildings, connectivity, analytics, there's packages out there that run in clouds that'll actually analyze your data in your building, your HVAC, your power, and tell you where you need to have corrective actions. And that didn't exist 5+ years ago. So cloud technology's changed a lot of that. When you look at it square footage now, you're really looking at, when you looked in the past, especially from a control manufacturer, you're looking at, oh, I'm going to go target energy. Well, when you really look at energy, it's a small piece of the building compared to, in this example, square footage and the cost per square footage, in other words, rent. So just think about, we're looking at solutions nowadays that are looking at occupancy and how much occupancy a building has, and how do we optimize that to where maybe we don't need as much square footage anymore. We're doing right now 3 different pilots with consulting engineers to help analyze that because they want to bring that to their customers. And then where are we going for the future proof? I look at IP as a way to get there. We may not know what the technology is in the future, but boy, I know if I have an IP connection all the way through an IP Ethernet network, I have a lot better chance of piggybacking other technologies onto there. And the other last thing I'm going to say is we did a building in New York. It was the first registered well building with the well certification. They actually charge a premium, according to them, of 15% for their rent. And I'll show you a use case towards the end here that'll give you some more details. So we're seeing that because of the wellness, because of the connectivity and the integrated. And Division 25 is a big part of that. So when you look at what are the customers expecting, when you look at open, efficient, engaging, and flexible, I look back at the last 10 plus years, and that's kind of what the building management, the interfaces, all we're trying to accomplish anyway. So that's not really that new. What is new is we talked about maybe occupancy and occupancy operator needs and how that's evolving. And then you look at that, that's a trend that's starting to change. So that's expanding beyond just efficiency of the building. Now we're looking at user productivity. We're looking at things like occupancy in a building. And of course, I don't know what conversation I don't have without cybersecurity. Schneider has an entire team for cybersecurity to look at how our solutions are, and we have a complete framework of how we design our products. Because when you think about it, if you saw those products in there, a lot of those products actually work in industrial factories. They work in utility plants. So it's not like I'm just going to have someone maybe get into my building automation. They could get into my factory. They could get into the utility company. So when you think about it, Schneider is way beyond just one section, or one market. And so they've got to look at this as holistically across all our products. And so there's a team that works across all our platforms to make sure it is cybersecure. When you look at some of the trends driving information technology and operation technology, you look at productivity. We're starting to see that. We kind of mentioned that before. Productivity is a big deal nowadays. Remember we talked about energy being a smaller piece, real estate being the next piece that's larger, and then you get into things like productivity. Jones Lang LaSalle quoted they have a famous 3-300 or 330-300 or 1990, which is relating energy to the type of impact of energy versus the impact on in performance and productivity. So that's the kind of stuff we're starting to see now. When you look at energy performance, we're starting to see a huge increase in net zero buildings. You can see the growth in the last 6 years. We talked about premiums and then cybersecurity. As Jack talked about, we actually had a presentation for ASHRAE this year. We were asked to come do that presentation, so we had an honor of doing that. The information was generic in nature, not really related to Schneider, though some of the technologies and best practices were related right to the technology that we have. So what is an intelligent building? And I get this all the time. I'll talk to a consultant or an owner, and they'll say, we want a smart building. We want an intelligent building. And the first thing I ask is, what does that mean? How do you define that? What are the KPIs? How do we measure that? How do we know when we've done the right thing? And usually I get a stared look in that case. So why don't we try to define what we're thinking of as a smart building? So when you look at it, maybe this is a vision of what an intelligent building might look like. Members of the staff come, they arrive, they have a card reader, they get in their parking garage. Maybe they have card access, and then part of that they have video where it actually recognizes them, records it. Nowadays they have license plate recognition cameras and so forth that'll be able to unlock or open a door or record a parking garage and who's in there. You've got, employees. Maybe there's, we're starting to see a lot more with EV, electric vehicle chargers, which creates a whole nother challenge for buildings because it's typically on the grid. And so what happens is, how do you manage that? Also, I was involved in putting one of these in America years ago in a university, and they asked me, well, how do we turn this on and off? I said, well, you got to hook it up to something that's going to either have it on or off, and they just chose to leave it 24 hours a day. So anybody could pull up and just charge. So those are kind of things you ought to think about when they affect your utility bills as well. And then you look at your occupancy. Nowadays, we're seeing mobile apps and things that the occupant or the tenant can actually change their environment. I'm working with a couple companies right now that are building new buildings, and they want this type of application. And when I asked them why, they said they want to use this as a recruiting mechanism to get folks that are coming out of college to come to their company, because this is one of the selling features they're going to have, is their own occupancy comfort. And then you look at the environment from a phone, apps, so forth, whether it be a sensor. We kind of just talked about that. Then you look at things like Alexa. Now you say, well, that's kind of impractical. But we have actually a hospital that we're working with right now that they have some patients that are in, I'm going to say, a critical need where they can't literally use their arms to adjust the temperature. And so what happens is they actually wanted to put an Alexa in there so they can actually control their temperature in their room, the lighting and the blinds. We're starting to see a trend not only from, that's kind of unusual as a use case, but we're starting to see more and more of that trends from the mobile apps. Then when you look at the control, of course, now we're back to the HVAC system and optimization, optimal start-stop, and all the other things associated with the normal HVAC. Then you look at the facility manager. Is he running reports? This is your typical building, all the other stuff kind of being more of the link and the intelligence. Then you look at the security, because there are integrations between the two. One of the use cases we have is an active shooter profile, to where the security would actually give you a signal, electronic or hardwired through like a duress, that would activate a active shooter sequence, controlling lights, blinds, and so forth. So we're starting to see this where there is a link between that. And then the last piece is, how do we measure KPIs? How do we measure, say if you have a portfolio of buildings, this building's cost per square foot, cost per BTU versus other portfolios. And how do we do that in the dashboard? One of the things I always ask facility managers and energy managers is, I go there and I'll have a conversation, what are you doing to save energy? Oh, and usually the answer comes back is, oh, we're very energy efficient. I go, okay, that's great. What is your cost per square foot? And it's usually quiet. Okay, maybe you don't know that. Let's break it down. What is your cost per kW or kWh? And do you have a demand ratchet? How are you getting billed? And again, usually it's cricket. So they're measuring this on a back office view of getting a utility bill a month after it's already happened, and looking at that and maybe not even equating that to square foot. So there's a lot of ways you can do KPIs nowadays, even on occupancy. How much has my space been utilized? Do I have to have this much CO2 to help with demand ventilation, or is half the people gone? These are the things we think of when we think of smart buildings. So this is one way to look at it. Here's kind of another way from a different perspective, where controls being kind of part of that backbone, because it does do a lot of connectivity. And then you have things like, now we're starting to integrate to things where it makes sense for the customer. Interface to fire alarm, blinding and blind control, energy management, power management. We talked about some of the KPIs for that. We're starting to see buildings now with a ton of sub-metering, even down to the plug load level. And in fact, ASHRAE 90.1 actually has in the electrical section where 50% of the plug load has to be turned off after occupied hours. So we're starting to see more and more of that, and there's a number of solutions out there that are motorized breakers and monitored breakers to make that a little simpler. Access control, we kind of gave an example on that. Smart grid, one of the use cases we have is smart grid and that integration to automation, building automation system, and using it as a smart grid application, microgrid. And really, microgrid, smart grid, it sounds familiar, but there's actually some terminologies because there's some that are literally the grid, the PV, solar, and everything else is on the grid itself, and there's others where it's an island, and there's others you can actually separate it as an island so the building can run on that. So there's a lot of technology with smart grid and microgrids that I did not know, but we have a whole team that deals with that internally. So I learned a lot with that, but there's more to it than just saying stick in a solar panel. Building occupancy, again, we kind of talked about that with where the industry's headed now. And then we really talked about advanced services and web services. This has really helped the building automation industry because over the years, the HVAC control or whatever these other systems are have very limited capability to crunch analytics in. It's very difficult to do that. Typically, you have to serve that data up in some type of cloud or server arrangements to be able to calculate that and to give back a results. So that's just really changed a lot of what we can do in the industry because of this technology and the cost. The cost is very inexpensive. We have a couple solutions. Most of them work on Microsoft Azure Cloud, so most of them are using that or some type of other web services with Amazon or what have you. So look for those in the future because they're coming more and more. So let's look at it from another angle. So we looked at it from a building. Let's look at it from an ASHRAE. We kept talking about 90.1. There's a lot of things that ASHRAE 90.1 has: demand ventilation, energy storage, fan control. There's really some really unique things in there that they call for that would be rather difficult for the industry to actually achieve. And then there's a lot of electrical information that has to be done. And a lot of that, actually, we talked about that with the fault detection. There's things in the cloud that we can do for predictive and preventative maintenance nowadays. And all goes back to what is an intelligent building. There's a lot of ways to define it. So what is a Division 25 specification? So why would you need it? So here is kind of our perception of what the industry looks at. So, and it's a little bit of funny here. Take it for what it's worth. But this is really how the customer explained it. The project leader understood it. How the analyst designed it. How the programmer wrote it. How the consultant described it. How the project was documented, which is a very key thing. I see this a lot. What operations installed, how the customer was billed, how it was supported, and what the customer really needed. So there's a lot of, I'm going to say, a lot of folks in the daisy chain here or in the mix that can misinterpret it, what we're asking for. So this is part of our challenge is how do we relay what the owner wants to an end result? And how do we design it that way? And that's kind of really where our head was in designing our Division 25. So what is a Division 25? Obviously, it's an AIA master format. There is a section called Division 25 Integrated Automation. It is not widely used. There's a number of reasons for that. One being there's a contracting, go-to-market type challenge because it's not well known. And I'll talk about that. I'm sure there'll be some questions on that I'll dive deeper into. We're looking at this for high-performance buildings. So the idea is whether this is a higher education university, whether this is a high-rise, this is really, we're using this for that application. We have a whole Division 25 specification already developed for healthcare, but a lot of those use cases, there's quite a few of them, like over 50, And those use cases are really related to healthcare. So there was a need to develop one for high performance buildings because in a lot of cases, the ones for hospitals did not relate to an office building. We kind of talked about this up above, but it's really procured generally through the general contractor. And I say general, but it could be construction manager, what have you. There's a lot of different, could be a design build contractor. I'm using general contractor very loosely. It does include cybersecurity and IP architecture. So one of the things is in the Division 25, we wanted to find, if we're connecting the systems, we want to be as cyber secure as possible. We may not be able to protect all the subsystems, but we're going to at least have something to where from the outside world we can actually protect it with a firewall. So that was kind of the intent. It doesn't have an all-encompassing Division 27, for example, in there, but it does allow for securing what the connections are. And then, of course, an IP architecture gives you a couple different layouts, and it gives you an example of what the technology flow diagram might look like. Now, in our vision, wrong, right, or indifferent, it was not meant to replace other divisions. So our Division 25 spec is around 30 pages. It's basically defining some of the cybersecurity IP architectures as we talked about, and then it really goes into use cases. That's what it's really about. We did not get into the whole points list, sequence of operation other than the use cases for 23, 26, or 28. And if you're not familiar, 23 is the HVAC temperature controls in there. 26 would be power metering, microgrid lighting control, and 28 is card access security. So those are the kind of divisions that are key for what we're trying to integrate. And 27 is another one, which is an IT technology path, and we're actually starting to see more things get pushed into that. But the intention is not to replace those and put everything into this spec. If we did that, this would be several hundred pages long, and that sometimes is a challenge for the contracting community. So the feedback we got from consultants was keep it the way we're doing. Now, could we have the same person doing 23 as 25? We get a lot of questions on that. Sure. Could the 26 be the same 25? Sure. Could 25 do all of this? Sure. So we kind of left it open to where you can copy, paste, do what you want to do. The format we give this out in is Word. So the idea is what makes sense to the owner, engineer, consultant, design, build contractor. You copy and paste what you want. We're not trying to fit into everybody's one size fits all. Take what you need. Some of the use cases may not help you, others will. But this is kind of the feedback we've had on why we did it. And then it shows use cases and so forth. So I'll go through that. We have 11 use cases today and growing. In our healthcare, we have over 50. So why use 25? Obviously, there's a big deal about interoperability with silos. And let me give you an example. I cannot tell you how many specifications I see out there in Division 23 for the BMS that'll say interface to the lighting control. Well, that is, that's a huge interpretation of what that means. There's no definition of what do you want to do with it. Really, all that means is I can connect one point to the lighting control system, and maybe I get that it's working or not working, and that's it. So, sometimes it helps to define what am I going to do, and that's just one example of many. Another one might be just tying to the card access system for after-hours occupancy. Well, what does that mean? So again, we're going to help define some of those things to help and give what the owner wants. So the intention is if this thing goes through 25, what you see in the use cases, it's what's going to be delivered. And it's a functional use case, a performance use case. And so those help define if the owner wants this, and I know it's in this, I know what I'm going to get at the end. There is some capital and operational savings. Obviously, with combining systems, you're starting to help do coordination. I was working on a project the other day where the entire metering system was all in 23. Not that that's an issue, though there's probably better ways of doing it. Nowadays, the switchgear is much more intelligent, even down to the breaker level. and including monitoring KW, KWH at the breaker level. So there's no reason why not to make an intelligent switchgear, a panel that's more intelligent that can just be connected, because there's no reason to put downstream meters when you can do it upstream at the source in a lot of cases. And of course, one of the things that BMS manufacturers and integrators are not specialists in setting up a meter. You know, there's more to it than you think. I've been through a few meter training classes. There's a lot more to it than you think. And in a lot of cases, I've had experience where the meter does nothing, or it's not reading correctly at the end of the job. So if you can get that back to, the gear, then I know the electrical contractor, the electrical manufacturer is going to get that right, because that's where the specialty is. And you don't have to take up extra footprint and installation out in the field to accommodate. And then we're starting to see more workplace efficiency and effectiveness where, as we talked about, there's 3 engineers we're doing a pilot with right now, and there's 4 customers that I'm aware of that are looking at that the next phase of way beyond what building automation can do. So what are some of the benefits of it? You know, we talked about this. It's what owners want. They're getting asked for this. So I've had a lot of, well, we haven't used 25 yet. Well, I have a number of consultants that are getting asked to use 25 by necessity, because of the fact they're actually wanting a high-performance building. They want something that meets a lot more than what they can deliver in 23. And they want things to work between siloed systems. So they're starting to push that more. And those are kind of the engineers we've been trying to really target across the U.S. Not that we don't target others, but, you know, really you could put 25 in 23 if you wanted to. That's fine. But really, there's a number of consultants that really put nothing but 25 in now on the higher end projects. And again, you'll see some that are just, you know, don't require that. That'll be just this traditional 23, 26, 28, and you'll see others that are 25. So it's starting to be a trend now. We're getting asked to present and share our story of 25 more and more. I was in front of a consultant 2 days ago, and we had this very same presentation for 20 engineers in their office with a lot of good feedback. So what's the outcomes? And we talked about this. They want efficiency, quality. They want a productivity improvement. What are some of the other things that are combined with this so a lot of things we do with integrations is we always encourage anybody that is going to integrate multiple systems together by different manufacturers to have some type of TVDA, which is tested, validated, documented architectures. That's one thing at Schneider we've done very well is all of the integrations we have with, I'm going to say, third-party companies, things we don't make. For example, we don't make lighting systems. So we partner up with a few of them, and the ones we do, we actually create TVDAs for so that the integrators know how that integration works. And remember what we showed earlier on that time frame of how it was documented, the project? We have documentation of how that works so that after the job's done, it can be supported as well, rather than I don't know how this worked the one time. And then what are some of the other things with the analytics and fault detection we're doing now and we're seeing in the market? We're seeing things that will actually help you do some ECMs, energy conservation measures, rebates, verification, and so forth. I actually had a consultant once that asked me if we could do parking lot lighting control and monitoring the amps of them or the energy, because they wanted to get rebates from the utility company and to get an extra rebate if they can prove through verification that they are saving. So there's all kinds of applications even outside of automation systems. So let's look at a couple of use cases here. And I just picked a few of these just so you know. So when you look at a use case, we look at this as here's what you think would happen. In the beginning, you identify, the owner tells you what, where, and why. What do they need? How do they measure? What's important to the owner? And then from there, you figure out, well, the owner wants this. Then what are the teams within the owner's organization is actually going to manage this? What does it mean to them? whether it's a building facility manager, whether it's an energy manager, whether it's a security manager, you can see it goes on, what those functions are going to use this system for. And then what are the resources that we need for this to affect these different departments? And then what's the technical components we need to put together to make all this happen to get the mission of the system? Well, you'd think this is how we started off every time. In reality, it's completely opposite. We throw a whole bunch of stuff at it, not knowing what the owner wants, okay? We just throw technology, and then we just throw a whole bunch of people at it and install it. And then we assume all these functional teams are going to inherit it and know what they're doing with it. And then we assume that it's going to meet with the mission of the customer long term. And that's kind of the challenge we have. Because of this challenge, you're starting to see other things like design build, IPDs that are trying to turn this trend around back to the way we had it before, which was, let's start with the mission of what really brings value before we just start installing a whole bunch of equipment. Because I always say, do I need all this? No, not if it doesn't meet what the owner is expecting. And sometimes the challenge is between the owner or the developer and the consulting engineer. Without communication, that is not always well defined, and that is a challenge in our industry. So let's look at a use case for room control. So the idea is, and we actually have 3 different use cases for room control, actually 2 use cases, excuse me. One's kind of a simple one, where how do we streamline the HVAC system to work with lighting control in a basic environment, on, off, and so forth. And there is a need for trying to combine systems to save with duplicate equipment. A lot of times I was working on a hospital up north, and the shade and blind control is in like division 8 and 12. So when you think about it, it's completely siloed from the BMS. So what we found out was, or division 25 for that matter, 23, 25. So what we found out was they were putting in a whole separate system to do that. And you just start having conversations about, couldn't we combine that into the same control system that's already in the building? I've already got to have something in there for controls. And then you got to figure out, does it make sense? If it's pretty complex with scene control and everything else, then you might want to have a true lighting system. But if it's truly occupied, unoccupied, on, off, that type of stuff, and even when you get into daylight harvesting, that's the kind of stuff we can still do. So again, it depends on how complex it is. And then you can link that with the controls into card access, video analytics. There's actually video analytics to determine whether it's occupied or unoccupied without having to put a sensor in addition. And then we actually have some support, which we talked about, for an active shooter. In this case, when you look at separate systems, you might have a lighting system, blind system, what have you. You might have a building management, they're in silos, or there's, as we talked about, interface to the lighting. And so you put one contact on there to say, okay, what does that do? If nothing else, it ought to help you control the time clocks. Because I typically see where the BMS will have one time clock, time of day, and then the lighting will have another. And I typically have seen where the HVAC will be off, the lighting's on, which doesn't make sense, and vice versa. Well, vice versa causes a little bit of a panic because they still want the lights on if it's occupied. System to system is another way to integrate systems. This is where, if the system's a little complex, where you do have scene control, you do have some really technical stuff that's in there that you're doing with lighting control, this is where you might want the systems. This is where you really want a TVDA, so you know what you're getting into by combining them. And this is typically done through a software interface. And with a software interface, you're getting hundreds of points instead of a point. And this is kind of where the industry's headed anyway, is software to software interface. And a lot of this is done with IP versus serial, which we kind of talked about a little bit earlier. And it's a little bit easier to actually get information of which, working and what's not working. Because a lot of times you'll see with the lighting, they may not want a full-blown, I'm going to say, computer or workstation there. They might want all that to be trained on the BMS, especially some of the alarms. Nowadays, they get into the lighting programs that are pretty sophisticated, knowing whether the lights, their time to failure. They'll get some alarms of when it's actually reaching its end of life. So there's some really neat stuff you can get out of lighting now. And then when you get into total room where you're actually doing it yourself, this kind of gives you an idea. I always get questions about, I see a smart trash can on there. Well, I don't know if that's here today, but I have seen restaurants that have smart cans, trash cans that compact the trash, and then they obviously are intelligent to go back to an alarming. But this kind of gets you an idea of where the future's headed. You can do blind control, lighting control, occupancy sensors and so forth, even card access. I've seen some applications where they want to monitor the room has card access to get folks in there. And then the idea is if they took a break, if it was still registered to them, it would be locked and they would have to get back into a card access. And the reason for that is because if they had valuables in there, you don't want to kind of leave your valuables if you might be worried about someone might be taking them. So there's some applications there. Next one was the intelligent breakers we were kind of talking about earlier. How do we combine some of that? And a lot of that's related to lead and ASHRAE to help with that functionality. A lot of times it's duplicate systems. I've actually seen where the same meters are on the same things that the gear has, and you're just monitoring it to a separate group because the folks aren't communicating between electrical and mechanical. You got it covered, that's for sure, but there's really a need to combine that when you look at it. And then here's an example of that is if we can make the power management system or the meters intelligent on that side of it, then we can just share data pretty easily. And a lot of that's pre-engineered, tested, TVDAs we talked about earlier. So there's a lot of things we can do to help with that in combining without having to add additional meters and so forth. And then another benefit to doing it and combining those from the electrical to the mechanical is you can get an added bonus now of things like utility bill verification. Power quality is a big one. There's a lot of areas that have brownouts or issues with power, whether it be not very clean power. This will actually help you identify what those issues are. If you're a hospital data center, this is normally you're going to do this anyway, but if you're a major high rise, it's pretty inconvenient to have a brownout in the middle of the day. So it'd be nice to know if you had tenants and given an explanation of why. Was it inside the building, something happened, or was it downstream with the utility? We have meters that could actually just give you that information now. Another one's plug load. We're starting to see more and more of this. ASHRAE, as we talked about, requiring this as their 90.1 2016. And traditional, you might see here's before, you might have a standard breaker panel to do the lighting or breaker and or lighting control. A lot of times you'll end up having contactors added secondary to the breakers, and then you have some kind of control mechanism. If nothing else, this takes up a lot of space. Architects are really pushing for space requirements or limitations in that in electrical rooms. So this does affect that, especially if you have multiple panels. There's solutions out there called motorized smart breakers, where you can have some of those that are going through and they're motorized, non-motorized. You don't have to have all of them, where you can actually link those together, and now you've combined all that into one. I'm going to give you an example here as we're finishing up of an exact graphic that we took from one of our customers to show you what Division 25 might look like. In this graph, and I didn't put the customer's name on here to protect them, but they have energy usage here. And you've got energy, solar, you've got production, because they can actually send data or energy back to the grid. Because we can actually connect now to weather services, URLs, we actually have an indoor air quality focus. And you can see here in the right, bottom right, this meant something to them because they had cooling on half the building, and you can see which the other half was in ventilation mode. And then you can see energy per system, and then you can see energy productivity year to date. So you can start to see how this might all integrate with a microgrid, with plug load, with all the different information, with ventilation, and how this might be valuable to an end user and even into the indoor air quality. I'm going to kind of skip through a couple of these slides real quick, but these are just some other things you could do per floor energy, mechanical plug. Lighting, control, we talked about that. Here's that one that I was telling you about, First Well Building in New York. I just wanted to highlight, it's the highest leasing rates in New York City to $125, dollars a square foot, and $300 for the penthouse. Nobody charges that much in New York City. They were able to do that by the WELL certification and all the different integrations they had, and they used that as a marketing arm to get the tenants in. So that's kind of where we're starting to see the trend now with that. The last slide I was going to have until I got into what does the specification look like is there is a Better Buildings results by Kpis that's out there. If you Google Kpis in this report right here, this is like the first report I've ever seen that really links a intelligent building to performance and of the employees, rated on absenteeism, turnover. So this is not something we did. This is something we piggybacked, but you can see the improvement over a smart, intelligent building per their documentation versus not. And there was a number of hundreds of buildings they did. This was all done up in Canada. So I encourage you to download that. But this is sort of the first statistics we're starting to see of if I do an intelligent building and I have costs associated, what does that do? How does that affect my performance of my employees and my company? And then the last slide I'm going to show you in our Division 25 spec, it's like 30 pages long. It is product agnostic. It's performance-based spec. Our name, I think, is only in there twice in the entire spec. None of our product names are listed. And it actually has a sample flow chart of how data might be able to be shared between the different systems to meet the use cases. So that's all I'm going to end up with here. I'm going to leave some time for Q&A. I actually went about 5 minutes over what I wanted to. So with that, I'm going to reach it back to Jack and say, Jack, are there some questions here that I can help answer?
Thanks, Brad. And now Brad will answer questions from the audience. Type your questions for Brad in the Ask Question box on your screen, and we will get to as many questions as time allows. Questions that we don't get to today will be posted online at www.csemag.com with the archived version of the webcast. And now remember to download a certificate of completion or a copy of the presentation. Use the Event Resources tab on the left side of your screen. So, Brad, let's get to some of these questions.
Okay.
So, first question, are the Schneider Electric use case examples of the Division 25 specs?
I'm sorry, are they asking what are they?
Says it are the Schneider Electric use cases examples of the US 25 specs. So these use cases that you've presented, are these examples of Division 25?
Oh, I got you. Yes, they are. And the idea with our 25, the way we're defining it is, we had a lot of, I'm going to say, challenges or arguments internally on what it is. What it is the things that have to be combined between multiple silos. So 23 connecting to something else, 26 connecting to something else, 28 connecting to something else. If it was purely something that did not connect to another silo, that was purely left or considered to be in its own event. So a lot of examples was chiller optimization. Do we keep that? Is that a 25? Well, really, in reality, that's probably a 23. So we try to look at things as how do we really use 25 as an intelligent building between siloed systems, wrong, right, or indifferent. I'd love to have your feedback if there's another way to do that. Okay, what else you got, Jack?
Okay, another one here. IT and VMS are very fast-moving fields. How often is MasterFormat Division 25 updated and issued?
Okay, so that question's a little open-ended. So I'm going to relate this back to Schneider. This is a living document for us. So far, we started to develop this at the end of last year. Since then, we've already had 2 revisions. And when I say 2 revisions, it's really based on use cases. We started with 9 use cases, again, for high-performance buildings. We've added 2 more. So the active shooter profile was not included in the original, but based on feedback from a lot of our integrators in the market, we added 2 more. So the more use cases you've asked for, the more we're going to add. And so keep them coming. So we actually have this as a living document. I'm envisioning that we would probably update it at least twice a year based on feedback. And again, it goes based on feedback. From a national or AIA format, really it's not been used well. I don't know if there's any one format out there that everybody uses. I've seen it in many different forms of 25. Typically, I see it as a 100-page document that really combines 23 into 25. But again, that's not wrong. It's just a different way of doing it. Good question, so. Jack, what else you got?
Okay, here's a good one. Should we have a building intelligence rating program to complement the LEED and WELL ratings? We have a BIQ developed for Kpis previously.
That is an excellent question. We do relate to building intelligence quadrant. So that is something that we do relate to, though I need to actually, one of the things we do is as we get questions like that, we start doing more research. I'm not sure how we relate to it. If you're not familiar, the BIQ is really a percentage, 0 to 100, of what you meet in a building based on an integrated or intelligent building. It's really made for convergence of technology, which is really what 25 is. And then there's a point system that you do for each of the subsets. For example, there's some on power, some on microgrid, some on voice and data. There's some connectivity things. How do you maintain the building? All those things relate to 25. So our fault detection, for example, relates to maintenance. So there's a lot of things that it relates. I would say we affect the building intelligence quota a lot. I just don't know to what level. So I'm going to take that question and do some research and find out, how we might relate to that and what might the quota be that we might end up with on that rating. So good question.
There are a couple of questions that are relating to Schneider Electric website. One is, where can I download some of these documents within the Schneider website? And another one is, can you share the Div 25 spec that is developed by Schneider Electric, or is it available somewhere online? I think that you probably covered that, but if there's a link that you might be able to share, that might be helpful. Is there a slide that shows that link?
I actually did. So in the beginning, if you remember, there was that Proficient portal. And I'll be honest, we just finished the second wave of the use cases last week. So we are going to post the latest. If you give me a week or less, we are going to post it to our Proficient Web Portal. So that Proficient, if you remember, you register as mechanical or electrical engineers. If you go in there, I'm going to make sure this is available in a download fashion of a Word document. So that's where you'll be able to get it.
Sounds good. Next question, is Schneider working toward implementing dimming capabilities through the BAS so in the future buildings can comply with ASHRAE 90.1 and not need a separate lighting control system?
Oh, that's a good question. So the latest 90.1 2016, there's a 13 as well, which does not require this level, though there are efficiencies you have to meet. But there's pretty stringent requirements on lighting levels and so forth. I haven't researched that enough. I know you could do it system to system with a lighting control system. I don't know if our lighting control can do as sophisticated as they're asking. Now, I don't think I couldn't, but the problem is then you're doing a lot of custom programming to do that. So I'll have to do some research and get back to you on that one. That's a good question, and I don't know the answer.
Okay, here's another one. What smart circuit breaker functions are you suggesting? Are you adding CTs to each circuit? Is there a solid state circuit breaker that has these types of functions?
That's a good question too. So we have a product, and there's others out there in the market that have, ours is called PowerLink. And PowerLink is literally motorized breakers. You just pick which ones you want motorized. So it's the actual breaker itself that we put, we enable that to be motorized. Normally it does not come with CTs on it for energy monitoring, but there's an option if you buy it with a verification. There's a verification model we have. It'll come from the factory with every single breaker, depending on which ones you want. If all of them, some of them, it'll have circuit monitoring on all of them built in. So it all comes from the factory. And as you can imagine, that's huge labor savings out in the field. So it's basically a motorized breaker that you can add. You can have a model you can order that has CTs on it, and all that data will be shared for M&V. And on top of that, you actually can get statuses of if the breaker was tripped or not. So an added bonus to this. So good question.
Here's a tricky one for you. You gave an example of 2309.23.13 energy meters. With the implementation of Division 25, would you still keep the Division 23 section?
Was they referring to meters in that section in 23?
Yeah, well, the energy meters is part of the 2309.23.13.
Okay. Yeah, I mean, every case is a little unique. I would actually, if you could try to put those in either 25 or 26. Again, the specialty of, and when I say meter, I'm talking about a three-phase meter. There's a lot of single-phase meters out there that you can get information of simple amps off something that may not require a three-phase meter. But a single phase is pretty easy. So I think it probably depends. There's probably applications that do stay in 23 that are more simplistic. And there's probably some that are more of a entire system that you might want in 25 or 26. So I wish I could drive into more details. It probably depends on the project.
Okay, here's another one. When adopting Division 25 on a project, what are the key sections and other division specs that typically need to be updated or coordinated?
Yes, that's a very good question. So it's not as simple as just putting 25 together and hoping it all works. What we encourage is through either, so for example, one of the things we've done is we've gone back to our Division 23 spec, we've gone back to our Division 26 spec, we've gone back to Division 28, and those are really the sections we try to integrate with. 27 is kind of an up and coming with technology. That's really the network switches as well as Cat6 cabling, structured cabling. So when you look at those three of the key, we're really trying to get to a point where each one of those references back to 25. So there is some link between them on coordination so that folks aren't blindsided, if you will, to make sure we have that language. So whether that's already in the specs, if you're a consulting engineer, you want to make sure that you coordinate between 23, 26, 28, that language is referring back to 25 to make sure that integration happens. In 25, the way we've written our spec, it does reference all those sections, including back into the blinds and shade control. And the way we've done our Division 25, we note things in there. So there's a lot of things are in red, and there's some key notes at the top that it says red or optional. So there's a lot of stuff like when you reference the blind and shade control, it's in red because you may not want to have that use case. So if you take out that use case, you take out that section. So a lot of the stuff in red, it kind of keys you in is it applicable or not applicable depending on your project. Those are good questions.
And those are good answers. And we have time for one more question. And here it is. How do you avoid electrical, mechanical, and controls contractors from pointing the finger and saying the other guy should have had it included?
That's a good one. So, well, part of that is having a detailed specification. And kind of like I talked about with the previous question, having a Division 25 helps a contractor, if you will, in the middle of this saying, hey, I've got to coordinate this. That's what 25 does. So if you link the other sections together, there is a person to help do that. If you don't have a 25, you're going to get exactly what you're talking about, unless things are really well documented between the divisions. And in my case, they typically aren't. And so that's one thing that will help with finger pointing, if you will, is a 25, as long as everything's referenced back and forth correctly. Good question.
Good answer. They were all great answers. Thanks for the great questions, and thanks again to our great speaker, Brad Bonfilio, for sharing his time and expertise. I'd also like to extend a special thanks to our sponsor, Schneider Electric, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it, because we use this information to improve our webcasts. Finally, on behalf of Consulting Specifying Engineer and CFE Media, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.